All right, we'll start with letter A. How do you write that in radical form? How do we write it in radical form? Do you want me to look at something you wrote down yesterday?
Oh, is there the three parentheses?
Yes, the 3 will go down and around. It will become an index. Here's the radical. The x goes underneath, and the 1 will stay high. It'll stay an exponent. So I can put parentheses and put the exponent there. Now it's kind of interesting. Sometimes it's most beneficial to have the 1 stay up high outside. Listen, sometimes the 1 you're going to want to put right here. It's equivalent. So you can put the 1 outside or you can put the 1 inside. All right, Rowan, you try the next one. Letter B, put it in radical form.
So you put the y in the radical.
Yep.
Put the y on that side.
Right in that little check mark there.
And then you do the parentheses and put the just like it.
Okay. The y is inside. Parentheses 4. Good job. Okay, Jaden.
Or 2, 3 on the outside. And then you put in parentheses 2.
Good. Okay. What is the difference between 1 A, B, and C and 2 A, B, and C? Yeah. Number 2, there's more chances to simplify than number 1.
Use the calculator.
Yeah. So this is just X's and Y's, and this is numbers. So in your book, this would say without using technology, because they really want to see you showing the steps of simplifying, showing the comprehension, so that if it was variables, you could go through steps. So let's show work on simplifying these. Whoever said you can put this in a calculator, you're right. The calculator will give you the answer for all of these, but we're going to require you to show work on them. All right, so the same thing as number 1. I'll bring the denominator down and around and it'll become the index. And the numerator, that 2 stays up high as an exponent. So I do what's in the parentheses first, the cube root of 64. And so I'm going to use my list of everything raised to the 3rd power. 1 to the 3rd is 1, 2 to the 3rd is 8, 3 to the 3rd is 27. 4 to the 3rd is 64. So that means the cube root of 64 is 4. And then we do 4 squared to get 16. All right, Liam, you're on number 2. What do we do for number 2? Yeah, letter B. Yeah. Okay. There's something extra going on in this one that hasn't been going on yet, and it's negative. So negative exponents become fractions because they really indicate division. So once you put it in fraction form, you put it under 1, the exponent will become positive. And that really should be your first step. So I'm going to put 1 fraction bar. 16, and I'm going to put a positive 5/4. So far, all I've done is change this from a negative exponent to a positive exponent by putting it under 1. And then I'm going to rewrite this as the 4th root of 16 to the 5th. And I don't know the 4th root of 16. Maybe I'll look at a list. Oh, it's not on the board. So I have to think about every number raised to the 4th power. So 1 to the 4th is 1. 2 to the 4th. Oh, that's 16. 2 to the 4th is 16. So this is actually 1 over 2 to the 5th, which is 1 over 32. I'm really curious if you put this in your calculator, if it's going to give you a decimal or a fraction. Does anybody want to try it? Not many calculators out in the room. I'm going to do it. Gives you a fraction. Calculator gives you the answer. Letter C. I'm going to wait. You go ahead and do letter C. I'm going to call an Evo for the answer. Yeah. I can scroll out for you, Israel. What's the answer, Eva? What's the answer? He's just like, did it do it for you? You can do it in your head pretty easy. I can't hear anything she's saying. That's the word for me anyway. Oh no. 1 9. It would be 9 had it not been negative. Since it's negative, it's 1 9. Yeah. Outside the door. Okay, so we put it under 1 and we make the 1 positive. And so this is 1 over, bring the 2 down and around. And that would be the square root of 81 to the 1st. Typically, our little 2's are invisible. So you don't have to write the little 2. You can make it invisible. And then, so the square root of 81 we know is 9. So that answer is 1. Okay. All right. If you guys want to log into your assignment yesterday, I hope you submitted it. I think you'll be able to reopen it. I tried to set it so you can reopen it. So log into Big Ideas. I just realized I marked you absent. Let's fix your attendance real quick. All right, you guys. Who had a question, couldn't get one right, or just need a little help? 14. I'll do 11 and 14. You hit refresh and you still can't see? I'll go to past assignment.
Find out.
We'll just submit it.
Yeah.
I got it. Oh, I thought we were doing a part 2.
No, I'm going to take questions first on yesterday.
Can't see anything.
It's loading. Do you not see the little?
All right, we'll do 11 first, and I'll do 12 as well, and then I'll do 14, and then if anyone has any other requests. This is to not use technology, so I'm going to think about this in radical form. It's the fifth root of negative 243 raised to the first power. Now, without a calculator, it's kind of tough. The reason it says don't use technology is because they don't want you just to put in the problem like it looks. They want you to think about the process and how to show work. So, since it's a fifth root, I'm going to think about the list of numbers to the fifth power. 1 to the fifth is 1. 2 to the fifth is 32. 3 to the fifth. I think that one's 243. You can check. You know, check in your calculator. What's 3 to the fifth? 243. But now I have to check negative. Can I get a negative 243? So I'll do negative 3 to the fifth in my calculator to see if I actually get negative 243 out. And you do. Odd, if it's an odd index, you can get a negative. So this answer is negative 3. Alright, I'll do 12. Bring the 3 down and around. This is the cube root of negative 64 raised to the fourth power. So now I have to think about the list of everything to the third power to do a cube root.
It was right down something.
And I see 4 to the third is 64. So this would be a negative 4 to the fourth power, which is a positive 256. So you might have put in negative 256, got it wrong, then tried positive and got it right, but not really understood why.
Yeah, I don't understand why.
Right, you're just guessing and checking, but it's these parentheses, like a negative to the fourth will always come out positive.
And then, because I got negative 256, and then I put it in, it was wrong. Checked with the calculator, put the parentheses around it.
Okay. All right, now I'll do 14, and then if there's any more. Okay, so 14 has a negative exponent, not a negative base. So you want to start by making it a fraction. So we're going to put it under 1 and make that 7/4 positive. And now it's the fourth root of 16 to the 7th power. And so if I want to recall what fourth roots will be, I'll think about a list for everything to the fourth power. 2 to the fourth is 16. So this will be 1 over 2 to the 7th. Is 128. 1 over 128. So I showed a lot of work, even though the calculator will do it.
Trying to simplify it.
Okay, put it in fraction form. Today's assignment though has decimals in it, but it has you like clicking the decimal, not typing it. Okay. All right, we're gonna do a little word problem, and then today's assignment. So head to page 422, and read about depreciation. This is accounting. Okay, so depreciation is a really important term in the world of accounting. This is an ultrasound machine. How much did the hospital buy the ultrasound machine for, Rowan? How much did it cost?
$50,000.
$50,000. Medical equipment is pricey. The hospital expects the useful life of the machine to be 10 years, at which time its value will have depreciated to $8,000. So after 10 years, it's still worth $8,000. The hospital uses the declining balances method for depreciation. So the annual depreciation rate in decimal form is this formula. N is the useful life. So that's the denominator. S is the salvage value. That would be the 8,000 that it's worth after 10 years. And C is the original cost. So it's 1 minus because it's like 100 minus the amount it goes down. Like 100% or 1. So we're plugging in the S value, the C value, and the N. And from there, it's pretty much calculator work. It's 0.167. You convert it to a percentage, and the annual depreciation rate is 16%. Any idea why anybody would care how much their equipment depreciates? Or why do they say how much it's worth over time? Anybody? Anybody? Jaden? Why does it matter?
What? I'll write it in my book. I'll be paying attention.
Okay. Trevor, anything? Yes, for reselling purposes. It's also important for taxes. So every company, kind of every year, when they do their taxes, they say how much their company is worth or how much money they have in the bank. And so if they just spent $50,000 on this machine, it looks like they have $50,000 less. But actually, that money is still a part of their business. It's just in the form of equipment. So, and you can Google and read about this if you're interested in accounting. I mean, this is cool. This is actually accounting at a school of medicine, UNC School of Medicine. So these are people maybe going to become doctors, but they're taking business classes because if they're opening their own clinic and they're having their own equipment, they're going to want to know how much they should depreciate it and how much it's worth over time. So you have to pay taxes on certain assets in your company. Here it says the IRS offers tax benefits for medical practices and allows a portion of the cost of qualifying equipment to be deducted from taxable income. Bonus depreciation allows for 100% upfront deductibility of depreciation for qualified property. So there's certain tax breaks and things that people who own medical equipment want to be aware of so that when they go to pay taxes, they're paying less in taxes. And it's not just medical equipment, there's also like farming equipment, factory equipment, other types of capital like cars at a car dealership. So if any of your parents or anybody in your family owns a business, talk to them about how they depreciate their equipment. and you can get, you know, some real life info about, especially if it's a small business, you buy a computer, how much is the computer worth? Is it still worth that in 2 or 3 years? How does that affect your taxes? We talk about that. Okay, so let's try calculating this ourselves. So we're on page 422, number 20. What would be the depreciation rate if the salvage value is 6,000? So in this case, the N will still be 10 years. The salvage value is 6,000. The cost is still a $50,000 ultrasound machine. And so here's our rate. It'll be 1 minus, big parentheses, 6,000 over 50,000 raised to the 1/10. I'm just going to simplify this for my own purposes. I'm going to reduce it. The zeros can cancel out. So this is actually 6 over 50 to the 1/10, which would actually be 1 minus 3 over 25. All right, give it a go. Try to put that in your calculator and see what you get. What would the rate be? I bet some companies will buy and sell equipment. Like if you can sell it more than the depreciation rate, I think you make money that way. Do you have a calculator or anything?
No, I don't do that.
You can use the Google one if you want. Google Scientific or Desmo Scientific. Calculator in the back there, Rowan? Did you get an answer?
0.191 approximately.
That's correct. So since you have to round it, we'll use a squiggle line. 0.191. We'll rewrite that as a percentage, and the depreciation rate is approximately 19%. And we just looked it up. Currently, they're depreciating medical equipment at 30 to 50%. And I think that might be because technology is updating so quickly that maybe in the past, like an ultrasound machine would be relevant for 10 years, and maybe now with the way things are updating, it's only relevant for like 5 years. So it's losing value more quickly. But if it still works after it's gone down to a value of 0, it's kind of sitting in your business, and it's technically worthless. But if you're still able to use it, that's a good thing. You don't have to claim it as part of your business. So it's a good idea to take good care of your equipment. Keep it going. All right, now we have to do these. Actually, let's just go to your assignment. And I'll do some of your homework. I'll do 3 of your assignment problems with you, and then I'll be done, and you guys can finish. Is it there yet? If you go to Big Ideas, you see 5.1 Part 2.
Yeah.
Okay. So this is your assignment today. You have the rest of the class to work on it. It really is nothing like anything we just said. So I'll do this for you. Okay, I'm going to start with number 2. Find the real solutions. So do it on paper and then just pick your answer so that if you can't pull it up tomorrow and you want to ask questions, at least you have on paper what you were working on. Or do it right in your book. Do it right in your book if there's room. Alright, you always want to start with isolating the base. So the base here is the x to the third. That 5, you want to divide first to isolate the x to the third. So first I would divide both sides by 5. And then the problem is x to the third equals 216. That's okay, you can say. And then you want to use a root to cancel the power. So here we have a power of 3. So we're going to do a cube root on both sides. Third root and a third root. And a cube root is the perfect opposite of a power of 3, so they cancel. And then we have x's, and the cube root of 216 is 6. So that answer is 6. You can check that. The mistake people made when we were square rooting, we already did this before with square roots, is that people would cube root as the first step instead of dividing 5. So make sure you isolate. Anybody have any questions? Did everybody get number 2 right? Okay, next one. Alright, number 3 already looks different because it has parentheses. When I look in front of the parentheses, there's no number, and when I look to the right of the parentheses, there's no number. So these parentheses, the base of the exponent is already isolated. So we'll fifth root both sides. We want to cancel out the power of 5 and do a fifth root. And sometimes we're supposed to leave it in perfect radical form. Sometimes there's decimals. Clearly the options here are decimals. So we'll go ahead and use the calculator. The root of 5 cancels out the power of 5. And I have x plus 10 is the fifth root of 70. So does anybody need help getting their calculator working? 5 second exponent 70 to get 2.339 approximately. Yeah. All right. Thanks for letting me. What did I say it was? 2.339.
That's inside. This is outside. Click 5, and then you click inside. And then you go 7. Press enter. Why is there an answer right?
I think it's negative 7.66. Did you guys find that in your option?
0.66. Yeah.
Oh, thank you. So you can't see that here. You have to scroll down in the options.
The calculator enforcements, I'm sorry. So that it doesn't confuse the problem.
Should I do any more? You guys got it.
I think I got this.
Yeah, why don't you guys work and then let me know when you get to one you can't figure out.